Hi guys, how are you? I hope you and your family are doing well. So today I'm gonna talk a little bit about section 7.1. It's about normal probability distribution. So normal probability distribution is probably one of the most important continuous probability distribution. Okay, and what's the continuous probability distribution? Well, actually we talked in section 6.1 about continuous probability distribution. So we said in section 6.1 that variable x is continuous if x can take on any value in a line interval. So for example, let's say x is the height in centimeters of a New Yorker. Height in centimeters of a New Yorker. Okay. Now, so x can be any real number in the interval. Let's say, so the height of the shortest New Yorker is, I don't know, let's say 20 centimeters, and the height of the tallest New Yorker is 280. Okay, so x can be any real number between 20 and 280. It could be 30, 40, or also it could be 30.5 or 30.51 or okay. It can be any real number. Okay, so x, in this case, x is continuous. Okay. So now what we do with the continuous variable, well, actually we model continuous variable with a function. Okay, we use functions to model continuous variables. So with a function called actually probability density function. And the graph of f of x is called a curve. Okay, so for example, so let me explain here what I'm talking about. So here's my x-axis. So here's my variable x, okay? So I have my variable x, and here's my function f of x. So let's say this is here, this is f of x, the probability density function. So this is my probability density function. Okay. Now, if you take two values, let's say of x, let's say here's a, here's b. Okay, so now what's the interpretation of this function f? Well, if you want to find, for example, the probability that x falls in between a and b, so the probability that x between a and b, okay, so that will be, again, this is probability that x is between a and b. Okay, so to find this probability, the probability that x falls in between a and b, so what you do, you take the area under the curve between a and b. So here's my a, here's my b. So this area here under the curve, under the graph of f of x, so this area here represents, so this is the probability that x is between a and b. Okay, so is equal to this, the area here. Okay, so the area under the graph of f of x. Okay. Now let me just say that here probably that x is here I'm using, so here I'm saying x is strictly larger than a and strictly less than b. Actually the probability that x is strictly larger than a and strictly less than b is the same as the probability that x, let's say, larger or equal to a and less or equal to b. That's the same. That's also the same as the probability of x strictly larger than a, less or equal to b. That's also the same as the probability that x is actually larger or equal to a, strictly less than b. All these probabilities are the same, are equal. Okay, that's because probability that x is equal to a, this is always 0. Okay. Another important remark is that the area under the entire curve is always equal to 1 unit. So the area under the entire curve is equal to 1. Is always equal to 1. Okay, so what I'm saying is, in other words, so I have this function f of x. Again, here's my x, here's my function f of x. Okay, so what I'm saying is that the total area here under the curve, so the total area here is equal to 1. Okay, this red area here, the total area here under the curve is equal to 1. The total area is always equal to 1 in any continuous probability distribution. Okay, so well, and the last remark here is that this f of x, the height, is always larger or equal to 0 for any x. Okay, another fact, so let's just finish with this fact here. Fact number 3. Well, f of x is always larger or equal to 0 for any x, for all x. Okay. So what I'm saying is that here, this is my x, this is my f of x. So f of x, so this is my x here, let's say. So here's my f of x, the height. So f of x, that's the height, right? F of x, that's the height. Okay, so this height is always positive or 0. Okay. Okay, let's do an example. Okay, so let's come back to this example of the height in centimeters of a New Yorker. Okay, so let's say x, that's the height in centimeters of a New Yorker. Okay, so here's my x. Okay, now let's say here we have the following function, f of x. So here's, let's say this is my function. This is my function f of x. Okay, here x is the height, right? So let's say here x is 170 centimeters. Here's 180. Here, let's say here's 190. Here, let's say is 200. Here it's 160. Here is 150, etc. Okay. So you see, guys. If you take the range, let's say from 170 to 180, so you see, so here the area between 170 and 180, so this is the area under the curve between 170 and 180. This area here, of course, is larger than the area under the curve between, let's say, 190 and 200, right? So what does this mean? Well, it means actually it's more likely to have a height in this range between 170 and 180 than between the range between 190 and 200. Okay, so it's more likely to have the height of a New Yorker between 170 and 180 than let's say between 190 and 200. Okay, that's because, so you can see from the graph here, so this area here is larger. So if you compare these two areas here, so this one, area 1, and let's call this area here area 2. So area 1 is larger than area 2. That's why it's more likely to have a height of a New Yorker between 170 and 180 than between 190 and 200. Okay, because again, this red area represents a probability. So that's a probability that the height is between 170 and 180. Okay, and the blue area represents, so this is a probability that the height of a New Yorker is between 190 and 200. Okay. Now, for example, so let's say that the area 1 area number 1, that's the red area, right? So the area 1, let's say, is equal to 0.34. Okay, that means that the probability that the height of a New Yorker between 170 and 180 is equal to 0.34, which is 34%. Okay. Again, it's just an example. So what I'm saying is, if the area 1, that's the red area, okay, if the area 1 is equal to 0.34, it means that the probability that the height of a New Yorker between 170 and 180 is equal to 0.34. So that's 34%. Okay. So now, so let's say we know. So we know from the graph. So from the graph, let's say we know that probably that the height of a New Yorker between 170 and 180 is equal to 0.34. Okay. 0.34, or that would be 34%. Okay, for example. Now, let's say we have a sample of 50 New Yorkers. Okay, so the question is, how many among the 50 New Yorkers, let's say, how many with height between 170 centimeters and 180 centimeters among the 50 New Yorkers? Okay, well, so what we do, so then the answer, so what we do, we have to multiply the 50 here by the probability that the height is between 170 and 180. So the answer here would be 50. So we have 50 New Yorkers times, and now we'll multiply by the probability that the height x is between 170 and 180. So that's 50 times 0.34 or 34%. So that's equal to 17. Okay, so we have 17 New Yorkers out of 50 with height between 170 and 180 centimeters. Okay. Okay, guys, I guess I'm gonna stop here, and I will post another video about normal distribution. Okay, so see you.